ಹಲೋ. FDP ಅದ ಆಮೇಲೆ ಮಾಡ್ತೀನಿ 10 ಗಂಟೆ ಮೇಲೆ. 10 ಗಂಟೆ ಮೇಲೆ ಮಾಡ್ತೀನಿ FDP ಇದೆ. ಬಾಯ್ ಬಾಯ್. हाँ भैया।
मैं कह रहा हूँ गणेश जी,
जैन।
स्लाइड आपको मिली थी ना मेल में?
हाँ
स्लाइड भेज दिया था मैंने।
हाँ हाँ, भेज दिया। सही।
हाँ, स्लाइड को ओपन कर लोगे ना?
वो क्या यार, रेडी है, आप ज्वाइन करो। सभी लोग ज्वाइन कर रही हैं, आप स्टिल।
अच्छा।
हाँ, 10-15 लोग आ गया। आप अभी तक आए नहीं। मेल भी मैं आपका मेल भी किया। लिंक लिंक आ गया है, देख लो आपका मेल। इवेंट हैपनिंग।
हाँ।
ज्वाइन।
वो यार मुझे इमेज दे दो ना यार, वो पीछे लगाने वाला।
पीछे लगाने वाला चाहिए क्या?
हाँ।
मैं ओके,
क्या
भेज
कैसे क्रिएट करूँ क्या?
भेजता हूँ मैं अभी। मैं रिकॉर्डिंग
चलो
शुरू।
मैंने कर लिया है, चलो ठीक है, मैं
ओके,
एडिट करा
रिकॉर्डिंग
दूंगा।
स्टार्ट किया मैं इसीलिए।
हाँ, बस रहने दो,
हाँ,
चलो रहने
ओके।
दो। हाँ।
जय।
फिर तुम सुनो, तुम स्लाइड ऑपरेट करोगे, मैं वेलकम वगैरह कर दूंगा।
हाँ या यू स्टार्ट करो, वेलकम।
जैसे ही स्पीकर आएंगे ना, तब तुम बोल देना।
मैं आने के बाद मैं बोलता हूँ, आप ऑन पे रहो, मीन्स अटेंड भी रहो बाद में।
ठीक ठीक
ओके।
ठीक।
हेलो।
अरे ये तो बैकग्राउंड हमारे नीचे सीधा दिख रहा है ना।
एक्चुअली वो दो मोबाइल में मेरा पर्सनल ऐड किया, लैपटॉप में वो वाला वर्जन मैं चेक करने के लिए किया था कैसे डिस्प्ले होते हैं।
मेरा बैकग्राउंड सीधा दिख रहा है ना।
हाँ, आपका क्लियर है, आपका बैकग्राउंड क्लियर है, सही है, आपको प्रॉब्लम नहीं।
जैसे आएंगे तो तुम बोल दो, वेलकम करना। वेलकम में क्या बोलना है तो?
वेलकम में वही बोल दीजिए, वेलकम टू द एफडीपी। उसके बाद में उसका डिटेल्स बोल दीजिए, देन यू कैन
क्या
स्टार्ट
बोल
इंट्रोड्यूसिंग।
तो अकेले ही
या वार्म वेलकम टू द एफडीपी। हाँ हाँ, वार्म वेलकम टू द एफडीपी डे 4 इसे बोल के देन। हाँ, डे 4।
तुम इतने ब्रीफ मैं भी समझ सकता हूँ, है ना।
और ब्रीफेबल पीपीटी में है ना, वो दिखाता हूँ।
है ना। आई
हाँ,
वेलकम यू टू दी।
यस, वी आर वेटिंग फॉर योर, ये क्या क्या बोल रहे हैं इसका, वो जोड़ के बोल दो। ज्यादा भी मत बोलना, कम भी ना मत। ओके, सही। 7 हो गया यार, देखता हूँ कितने लोग आ गए।
Good evening.
Good evening, madam. Good evening.
Hello, Harshvardhan. Hi, Dipendra.
Good evening, ma'am.
Good evening. Good evening.
Good evening to all of you.
Good evening.
Yeah.
Good evening, sir.
Good evening, sir. Good evening.
Good evening, sir.
Good evening, madam. Good evening to all.
Good evening, sir. दीपेंद्र, आपकी गायत्री मैम से बात हो गई थी?
हाँ जी, हाँ हो गई।
ठीक है, ओके।
सेम लिंक है ना दीपेंद्र, कल वाला ही?
Yes, yes, madam. Yes, madam. Same.
हाँ वही ट्रांसफर, ठीक।
मैं क्लासरूम में मीन्स डिपार्टमेंट ग्रुप में भेजा है मैम. You can forward that one.
हाँ हाँ, वो मैंने कल वाला ही कर दिया है।
वही है, दोनों दोनों सेम ही है.
हाँ वही दिया, वही सेम दिया।
Ganesh sir, make this slide full screen.
Okay, sir. Actually, इधर
आ गए सर, हैज कम।
Good evening,
Bala
sir.
sir has come.
Good evening, sir.
Good evening, sir.
Good.
Good evening, Bal Murugan, sir.
Good evening, sir.
Good evening.
Sir, good evening. Good evening, sir.
Good evening, professors.
Ganesh, sir, please full screen.
Okay.
Can we wait for another 5 minutes? Depends.
Sure,
Okay, ma'am.
No, only 22 participants are here. Let them join.
Okay.
भैया वो स्क्रीन शेयर करा तो है ना, वो क्लोज होता है। क्लोज मेरे को एडमिट नहीं कर सकता है, वो पूरा क्लोज होता है मेरा विंडो। ओके, नहीं वो आप बोलने के टाइम मैं करता हूँ। अभी पार्टिसिपेंट आ रहे हैं ना, आप स्टार्ट होने के बाद फुल स्क्रीन करता हूँ। ओके, हाँ, फिनिश होने के बाद ये। ठीक है, ओके।
Welcome, sir.
Welcome, ma'am.
Bala sir, welcome. Yes.
Yeah, thank you.
Sir, we are starting in 5 minutes.
I'm sorry.
Sir, we will start in another 5 minutes.
Sure, no problem. I'll hold on.
Okay, sir. Okay. Ma'am, now we should start. Actually, another
Yes.
speaker is also there. है ना, ma'am?
Yes. Okay. Depends, sir. You can start now.
Okay, ma'am. Okay. Okay. So I extend very good evening to all the participants present in the session. At the outset, on the behalf of organizing committee of the 2-week faculty development program on integration of WSN and IoT for agriculture, I extend my warm welcome to the renowned speaker of today's session, Bala Murugan sir. We heartily welcome you, sir, to the day 4 of the 2-week ATAL FDP on integration of WSN and IoT for agriculture. Uh, Ganesh sir, brief profile.
Yes.
Dr. Bala Murugan MS is a VIT University professor with extensive experience in developing and implementing educational technology, tools, and applications. An expert in embedded system and the Internet of Things, adept at engaging students in the learning process through creative teaching strategies. He is deeply committed to developing and innovative products in the field of artificial intelligence and the Internet of Things. He has published numerous research papers in reputed journals and conferences. So I would request every participant to this lecture to fulfill their research goals or commitments, career commitments. I welcome again Bala Murugan sir, and I request you to kindly move on with your presentation.
Thank you, organizers. I'm very happy to present my topic on AI and edge computing for the agriculture. So just give me a minute, I'll present my screen.
Sure, sir, sure.
You can share now, sir.
I hope my screen is visible.
Yes, sir.
Yes,
Yes,
sir.
sir.
Right. Good evening to one and all. I'm here to present something about how to use the artificial intelligence in the edge, specifically in the Internet of Things domain. Okay. And I'm happy about my introduction. Thanks, organizers, for the same. So I'll start with straight away with my topic since I have a very limited time. So let's take a use case scenario. What is this edge computing specifically in the scenario of IoT? We all know this particular standard representation of this particular data set, which we widely use. What we need to basically do here is that identify from the images what is this number and identify this number to be represented. We traditionally use any of defined neural network model to identify this, define the input data points here, and then what is my final output data elements for this particular number plate recognition here. Okay, right. So we define the input layers, define the deep neural network model. Evidently, now we are able to run this particular deep neural network models on these kind of microcontroller hardwares. Okay, that is where the role of edge computing comes into play. We have heard about running this on the cloud architecture. Now the focus is shifting towards running this on the edge architecture. Edge means that where my the data aggregation is happening is what we refer to what is called as edge in basic in Internet of Things. Okay, so in this particular scenario, I have a car and I have my camera and I connect this to my microcontroller. So this microcontroller would be able to run this particular deep neural network model and then evaluate what is the number plate that has been identified, and based on that, let's say it has identified it to be 2104, and let's assume 2104 is a registered car which can be permitted, so I approve it to pass through the gate. But just in case if it's a different number plate which doesn't match to my database, so I shouldn't provide the pass. So we take a decision in IoT to deny the gate pass. Okay, if this decision happens at the edge rather than every time going to the cloud, so that is where the role of edge computing plays a significant role, especially in the Internet of Things environment. Now, coming to the focus of our workshop, where we talk about the role of WSN and IoT in the scope of agriculture. And in this particular case, I've taken a simple scenario of how we can use this agricultural, smart agriculture in comparison to traditional agricultures. In traditional agricultures, we have farmers, we have the bullock carts, we have a lot of other animals being livestock being engaged for production, for monitoring, and then taking some decisions. But whereas with respect to IoT, the role of IoT in agriculture, now it has connected to real-time data monitoring systems. We get the data from IMD about weather forecast, so we decide what kind of crops we can start cultivating, and then based on that we apply the fertilizers. Today even fertilizers application process, pesticides and fertilizer is being automated through drones. I've seen 2 weeks back our past Indian captain Mahendra Singh Dhoni launching the Garuda aerospace drone, which is widely being approved by the Indian government on how the drones can be effectively used in agricultural field for pesticides in a precision agriculture model. Okay, so to that extent, we see how IoT has been integrated with the AI specifically to the agricultural field. If I need to put it into the TCP/IP kind of an architecture, I have my sensors, data collectors, and this goes through the gateway. So my physical node is there, and then I have my underlying network layer here. From the network layer, I establish any kind of communication networks. It can be mobile, it can be long range networks, it can be LTE networks or NB-IoT networks that we are widely adapting to the agricultural deployment today. And coming on to the application layer, we talk about the role of data aggregation and doing data analytics there. And also now we also are looking to build an expert system where microcontrollers can run the neural network algorithms being evaluated in the cloud and then deployed in the edge scenario. So now I'll take a very specific use case. I'll talk about only this particular use case and how it is being practiced in the agricultural field, which I have developed for my. Okay, here a brief introduction about this particular topic is whether I'm going to talk about weather forecasting and how it is going to play a role in agriculture. Okay, so this is the about what is going to happen tomorrow. Okay, I've taken a screenshot in my particular locality, and then what is the temperature, what is the predictions that has been given. And usually this particular predictions is given based on the data sets that is being captured by radars and other service providers, and they build their algorithms, and this is being put over there. Okay, and this is once other data that I've taken from this particular other activity, where what is being presented over here for different particular region and what is the likely heavy or dry or likely showers that is going to happen there. And if I take about last 215-year data that was available there in a public domain, what I see here is that the coefficient of variation that you can see over here is pretty high. You can see variation, that is what is being predicted and what is the outcome is almost 140% deviation in the predictions. So basically the rainfall prediction is still a significant concern with respect to IMD. Even here, if you can see, it is close to 60 to 80% deviation. Generally in the southern region of India, we have the rainfalls available in October, November and December. Heavy rainfalls happening during this southwest monsoons. And what we see here is that 40 to 80% deviation from, variation from the predictions. So with is still a concern in the field of rainfall prediction, which is again going to affect the agricultural productivity. Any change in the rainfall periods, it is again, and the amount of rainfall, again, it is going to affect the agricultural thing. And how the rainfall is generally predicted is that we have a nowcasting which we predict within 24 hours, short range for within 3 days, medium range is all about long periods of time, and long range again. And there are various methods by which we carry out predictions over here. With respect to nowcasting, what we widely use is the numerical weather prediction model. So we define the various physiological parameters of the weather with respect to temperature, pressure, humidity, a lot of other parameters. We create a mathematical model for all these physical parameters, all this physical parameterization, and based on that, we apply the numerical weather prediction models, which will give me an outcome of what is going to happen. And then what happens with respect to short range forecasting is that they widely use ensemble forecasting. And what is this ensemble forecasting is that for a particular given scenario, they'll start introducing error in the upfront, and then arrive at ensemble of numerical weather prediction models, and then they average from that particular ensemble model. So what is going to happen from the present 24 hours to 3 day scenario. So these are the two factors that is pretty important with respect to farmers. Let's say about providing the field with irrigation systems, or should I water the field today? There are some crops which are in South India where the irrigation and water conservation is a pretty big scenario. At least in down Pudukkottai district in southern part of Tamil Nadu, water is very, very essential. Even drinking water has become a concern in that particular scenario. So can I have a mechanism to preserve water, and irrigation has been properly carried out so that cultivation happens as planned? So with respect to the earlier scenarios, what it is observed is that due to the chaotic nature of the atmosphere, that it's non-linear in nature, complexity involved in numerical weather prediction models, because these are highly physically parameterized models. So a large amount of error gets introduced even during the initial assumptions, which IMD is trying to come down a bit better, at least in the given scenarios today. Okay, and I'm also touching upon few wireless technologies that is available today, which I've evaluated based on this particular wireless technologies. I've taken out the 3 wireless technologies, and finally I adapted LoRa as a wireless technology to be applied in the agricultural field, because of the factor that I have my nodes located at different locations in the agricultural field, and from there I'm starting to aggregating the data basically. So which means that, for example, I have a node setup which is collecting data 200 kilometers with the LoRa in my hometown, and I have set up the gateway at that particular agricultural field. I collected different agricultural data from that far field, and then this data actually comes to my remote place where I am trying to do some buildings, mathematical calculation. And the reason why I try to use LoRa is this particular reason. See here, the range is quite a good feature over here, and also the battery consumption is also very minimal, but this comes at the cost of data rate, minimal data rate. But I'm okay with minimal data rate. I'm just going to collect every 10 minutes just 50 kbs of data maximum. So this LoRa is pretty good enough for my particular deployment scenario. So I've taken this particular role, and let me introduce what is this edge computing that I'm going to apply in this particular weather forecasting. See, this process of edge computing is the process where the information, that is the data that I am going to collect from all the physical environment that I've put, whether it may be things or people, kind of smartwatch, I collect data, all this data aggregation. If I can bring a computer to that particular location and do some computation over there, that is what so decision is being taken at that particular locality here. Okay, so this is a sample of how the architecture looks like. Edge devices, I have fog nodes, which is like operating on gateways. I have a state-of-art data centers doing the cloud computing deployments there. Okay, but if I have to colloquially define edge computing, training an artificial intelligence model for a global scenario on the cloud and applying it for the decisions to be taken at the edge locally. So training a model globally and trying to put it for decision making in the local scenario. That is what is my own definition of this particular edge computing. And where is this going to be processed? As you can see from the architecture over here, I'm trying to put it over here, okay, to either it is things or people from where the data is going to be aggregated. So all other environments are, we are having a state-of-art computation facilities to carry out these particular deployments. So moving on, why we need to look on this particular edge computing is that these are the four major factors. First one is all about latency. I don't have to send the data every time for decision making to the cloud. I can take decisions at the edge, and saving this naturally will actually save the bandwidth. So I don't have to transmit the data, which saves the bandwidth. And privacy. So this is another important factor. When my data is all over the internet, there is hackers who are ready to hack into the data. And also the autonomy is given to the edge user who is going to deploy this particular implementation. So I have these four better advantages factors in applying the edge computing specifically in this thing. So talking about a sample edge computing model, this is what I deploy a sensor, and this reads the data. This advertises the Bluetooth through, if I'm using the Bluetooth in that particular case. And there would be a gateway which actually gets the data, encrypts and publishes the data, either MQTT or HTTP or kind of protocols that I'm going to prefer, and then onward the data depending on what kind of deployment. And finally, it comes to the cloud layer, do some computation, data analytics over there, and then based on that, decision making for business intelligence is being carried out, and then finally, based on the device, it has to go back. So now with this idea, I'm just proposing a software stack. So first of all, if I have to run my edge intelligence in a microcontroller, first I need a bootloader, and then I need to run it either on an RTOS or an embedded operating system or a custom operating system. Okay, and then I will have my encryption services put onto this thing, and then I'll have my storage services, and I have my network stack. I need my authentication system. I need my network layer and application layer protocols to run. All these things are, I'm trying to reuse from the regular the architecture. What is coming but in addition to this thing is that build a rules engine. And this can be done using the expert system. Expert systems are nothing but the neural network model. Okay, I'll show a final demo, if possible, how this expert system is being built from this particular software stack that I'm running. So with this particular architecture, what I did is that this is the one of the implementation that we tried carrying out. So I have my data acquisition from the sensors happening. So what I do is that all the pre-processing from the data collection goes to the cloud, and then pre-processing happens, and then I try to build a prediction model, and this prediction model is optimized for my end microcontroller deployment. Okay, and based on that, I deploy it on my controller, and the actuation happens over there. So these two are the physical process, but these are the cyber layer operation that is being carried out here. Okay, if I have to put it in little detail, I have my sensor and I have my microcontroller, and this microcontroller is running on a LoRaWAN network thing, and then this data goes to a server, and from the server, what happens is we pull the data to the cloud. And on the other side, what I also did is that I have taken a data from the Indian Meteorological Department 10-year data set with respect to various parameters, and then I prepared a training and test data set, prepared a model. This model was running using the long short-term memory, LSTM, bidirectional LSTM to be specific. So based on that particular BLSTM, prepared an adaptive model, and based on the accuracy parameter. So that model, I've deployed it on my end machine, and this goes to the microcontroller through this particular edge model. So stage 1 is carried out here, stage 2 is carried out here, and final evaluation, we have done it over here. Okay, we have tried a different method, and finally I observed LoRaWAN fits to the scenario because of the long range data communication. This is the data that I captured using this particular LoRa. What I did is that I did an encrypted data capturing process so that my data is secured enough from the portal from where I'm actually capturing the data over here. Okay, and this is the actual data that I am trying to get from this particular. I used a gateway that was provided by Tata Communications with respect to LoRa. Now, actually, Tata Communications has moved out from LoRa, but previously they were operating on LoRa. So I made use of their LoRaWAN gateway for instance. And the best part here is that whatever the sensors that I use and using the LoRaWAN and the functioning of microcontroller, I tried calculating the power consumption of this particular sensor node. Unfortunately for me, a mathematical calculation of this particular node read into 2.69 years with a 3.7 mAh battery. That was good enough for me to aggregate data every 10-minute interval of data coming all the way to my cloud and running on an edge intelligence was able to run with a battery life of 2.5 years, which is very good for me to be deployed in the agricultural field, so I don't have to worry about replacing the battery every other time. Okay. So this model, I think I've already touched upon the same LSTM model. So what I did here is that I focused on the nowcasting and medium range forecasting. And what I did over here is that I took this data and I tried capturing what is going to happen in the next 72 hours based on what has happened in the last 72 hours, basically. So based on that, I've tried predicting the factors for rainfall and the temperature here. Okay, and these are the results that I received from that particular data sets that I have evaluated. Tried evaluating for month on month with respect to these outcomes. As you can see, what is my actual and what is my predicted results over here. Okay, for with respect to temperature. And then with respect to rainfall, you can see there were little inconveniences when I am working with wide change in this particular actual inputs. That is because of the factor that my sensors is running on a not a commercial grade sensors, and these sensors can capture only minimal amount of data from this particular thing. And the problem is that it is running on an edge intelligence. I'm trying to improvise that particular edge intelligence model. So that is why the actual with respect to peaks, it is not exactly as predictions happens over there. Okay, so that was only SIM. And then you can also see by almost by I think 7 or 8 epoch itself, I'm able to reach the RMSE, better RMSE, and my RMSE, if I'm right, 0.36 is the RMSE with respect to rainfall forecasting for my thing. And it worked good for my temperature prediction models. I think close to 3 and 4 itself, it came pretty better. Started reading better. Okay, and TF Lite stands for TensorFlow Lite model. If I need to expand this is using the TensorFlow library, which I'll show a while ago. And then Lite means that I use the heavy model to be optimized for my microcontroller requirement, and then start doing the predictions for that particular scenarios that I'm trying to capture over here. So this graph gives me a picture of what is the actual true future and what is the model prediction for this particular given scenario based on the last 72 hours of data that I am trying to read from that particular my data portal. Okay, and from there I am trying to capture what is the outcome of this particular TF Lite model. And how I tested here is that I took the data. Actually, this was my home that is located in this residential area, and this is my campus where I connected the LoRaWAN gateway. And for this particular LoRaWAN gateway, without any LOS hindrance, I was able to capture the data. And then from this particular data captured with the support of Tata Communication, where we have erected a setup, and then I captured the data. And this data actually, this is the setup that I have used. DH2 and BMP sensor. This is the LoRaWAN node. This is running on the STM32 microcontroller, which is ARM M4 microcontroller on board in it. And the sensor is connected to a 3.7 mAh battery source over there. Sorry for this small thing. I think it will expand. Yeah, correct. So you can see the data capturing process from the humidity and temperature. And this is the actual LoRa data packets that I'm trying to capture. It gives the network ID, what is the data. You can see this is the actual 6-byte data packets that I'm capturing. The data rate channel is using the class 0 channel, as you can see DR0 over here. LoRa has class 0, class 1 and class 2 different kinds of, based on the data rates, based on different conditions that I am using. Okay, so now based on that, I prepared a graphical user interface, and this is the actual data that I captured. And based on that, I'm trying to predict the probability of rain for that given scenario. And here in this particular case, for all the input data sets, it gave me 0.49, which is close to 50% chances of rain for the next 6 to 24 hours scenario, actually. Okay, so these are the publications. I thought I have to show my yeah, 1 minute. Yeah, this is my I'll share this particular link of that is present in the GitHub. And what is this actually is that I've prepared the LSTM model, and this is running on the Arduino Nano 33BLE, which is ARM Cortex M0 microcontroller. I've tested it, and my model is actually running on an ARM Cortex M0. Okay, I'll run through the program, so I'll also share the code. I'm okay with it. So the data set, what I did here is that I used this particular Max Planck, which is the also called as a Jena climate data set. They give pretty good data sets available for the last 15 of data that I wanted to process. And I labeled my data, whatever that I wanted to work on, defined my features, and tried printing the data captured, whatever it is there. And from there, try to understand the heat map or the relation between the data, tried to understand the correlation between the datas, and then started pre-processing the data, and took the, as I already mentioned, I wanted to take only the last 72 hours of data, and I'm trying to predict for what is going to happen for the next 72 hours. I define whatever my deep learning hyper parameters, and I define my LSTM model also. Yeah, here is my LSTM model. You can see what is the model that I've tried over here, and I've ran it for 10 epoch on a GPU. It should actually run for close to I think 10 minutes, as you can see all the way here. So it tried completing in this particular period of time. And then these are my outcomes. I tried plotting this particular on different predictions. This is what I've shown in the TF Lite model. And how do I do this TF Lite model is that I need to read and start applying my predictions. Okay. And then what I did here is that convert into TF Lite model. TF is TensorFlow Lite model. So APIs are available given by TensorFlow Lite. So whatever the model that I have already captured, I've saved it into the model. Okay. So I use the model, input into my TF Lite converters, and from this TF Lite converters, I try to quantizing it. And based on this particular quantized output, I reduce my parameters. See how many number of parameters it got reduced from 5153. Previously, if I need to go back and show the number of parameters, same 5153. Okay, so I optimized it for my end requirement, and based on that, and then what I did is that I generated a header file. So the header file you can actually download directly and take your Arduino compiler and directly import this particular files. This is the Arduino program to import that particular TensorFlow Lite model that I have downloaded, and then start building your algorithm that you need to build your weather forecasting. So this way, your edge computing plays a significant role. Without even the need of internet, we can deploy the Internet of Things concept and use the implementation of AI into the agricultural field to optimize for different requirements, basically. So I'll stop all the way here, and I'll leave the floor open for questions if you have.
Good evening, sir.
Okay, sir.
Yes.
Sir, actually you achieved that around 3 kilometer of distance between the two LoRa.
Yeah.
That, what's the spreading factor you are used for this, sir?
I use the class 0 model. So without any line of sight issues,
Okay.
I was able to achieve this particular 3 kilometer, but that was actually supported by Tata Communications Gateway. So they had their model available for this particular deployment. So that helped me in deploying this particular implementation.
Okay. Oh, yes.
And also, if I'm right, I use this bandwidth 10, right?
Okay, sir. Sir, actually I am working on this. This is my research area, edge computing and IoT. If in future,
Okay.
if I required any help from
I'm
your
sorry,
side, I will
I didn't
contact you,
get
sir.
your name. May I know who is this?
Ganesha HS, sir. Yeah,
Sure,
Ganesh HS.
I will be happy to support.
Okay, thank you, sir.
Hi, sir. This is Manish Bansal from IIT Delhi. Which LoRa module you have used and at what frequency they were working?
Semtech LoRa module. I don't remember the exact model number actually. And frequency is 868 megahertz. That's the Indian. I mean, we can also use the 908.
Yeah, right, sir. Yeah, right, sir. We can use only 868 megahertz as per the
Yeah.
specification. But some of the vendors are providing 433 megahertz also.
We can configure, but we need approvals, but we can do it. I have tried doing it, but didn't test it for deployments actually. If you wanted to
Yes, sir.
set up as a private network, then you can try it actually.
Right, sir. Right. Thank you, sir.
Yes, sir. Sir, one question from my side. Sir, we are having one LoRaWAN module in our lab that is from Dragino. So,
Yeah, correct.
sir, that is having, yeah. So, sir, that can we use that? How means what will be the maximum range that will provide? Like, if we want to set up that in the agriculture field, and we are having 2 nodes and 1 gateway. So, with the 2 nodes and 1 gateway,
In
what will be
Dragino,
the
yeah, I'm sorry. In Dragino, there are, see, LoRa gateway is like 2 different gateways are there, and large number of gateways, of course. One is internal, one is external. Internal is like I wanted to set up inside my room and start aggregating data. And that gateway is like will work maximum 2 meter, 3 meters range, because the power efficient there is actually very minimal. But there are gateways that we can put it in the open fields, again available in Dragino. Based on the deployment, you can test it on the open fields. And as I see already in the schedule, I found that N2 technology, Mr. Subramaniam is going to deliver
yes, sir.
session on that. He
Yes,
is
sir.
the most renowned LoRa deployer in India. So you can get to know, even the devices would be available. We used to get from the same gentleman only. Okay. So there are models, different models available. Only if you can let me know which model number, then I can give an input, the range coverage, and based on that, I can give other inputs also.
Sir, what about
Sir, we are having the outdoor mode. We are having outdoor
LoRa
gate.
module?
I'm sorry. Come again, ma'am. You're having?
Sir, we are having outdoor gateway. That is
Okay.
the range
Again,
will
in
be for the
outdoor
fields
gateway,
only. Yeah.
and as I already mentioned, depending on the model number, the range also varies. Like I showed in my deployment, maybe I'll go back to the slide. In my case, I had a gateway deployed by Tata Communications installed in VIT premises in an open field. We have an 8-floor building. So my gateway is actually set up on an antenna tower and connected to my open space. This data capturing process also is an open space without any hindrance, basically. But if it is in agricultural, let's say in places where maybe I'll try to show my pictures. This is one of the places from where I'm actually using my gateway to capture this data set. Say, let's say if I have it in these kind of places, the trees are going to be a hindrance in these places, actually. So how do you capture data? Again, you need to depend on the kind of gateway. If you can erect an antenna and then set up, that would be happy to collect. In my case, I think I have
Sir,
the
actually,
gateway.
yeah. Sir, my students are doing one project on landfill fire detection. So there we are using the outdoor LoRa gateway and nodes. So that's why I wanted to know that how we can deploy it for collecting the data. Like we are collecting the data for gases, concentration, and pressure. So we can we use that LoRa or not? So yes, we can use it, and
yes,
further
yes,
we
we can
can
use
learn
definitely.
from. Yes, sir. Thank you, sir.
Sir, Manish Bansal this side.
Yes.
Sir, if we have two LoRa modules, can we communicate using them, or do we need a gateway, a special gateway for their communication?
See, LoRa architecture itself. Do I have the LoRa architecture slide? Just give me a minute. I think I'm missing the LoRa architecture slide. So the LoRa architecture itself is like from the node, the data goes to the gateway. From the gateway, the data goes to the cloud, and from the cloud, we go to the application. It's a 3-tier architecture actually. You cannot set up a sensor network node using LoRa. LoRa is a protocol. LoRaWAN is the network there. Okay, so LoRa is a long-range protocol there. So which means that it is going to send the data to the gateway basically. So you need a gateway to communicate the sensor data to the cloud or to aggregate basically.
So, sir, that gateway also would be having that LoRa receiver, right, sir?
Yes.
So we can basically we can make a gateway using Raspberry Pi and a LoRa receiver.
Yes, that is possible. Yes, that is possible.
Right, sir?
You can create your own gateway with that's the best part of LoRa.
Yes,
you don't need dedicated gateways from any particular. You can set up a private gateway using 2 different LoRa nodes.
Right, sir. And sir, one more question. As ma'am was asking, so do we need the LoRa from the same manufacturers, or the different LoRa modules working on the same frequency and same band?
No. LoRa packets can come from, say in my case, what happened is, I'll try to project that particular thing. So what I did here is that till capturing the data packets from LoRa, that is fine, I can decode. But here application layer, I used Tata Communications application layer because I didn't have a dedicated application layer in my case. But you can actually, if you are setting up using Raspberry Pi, any LoRa node can actually be used to capture the data. All LoRa, Semtech is the only proprietor who manufactures the LoRa nodes. There may be different vendors actually, but all comes from the Semtech module actually. So you can make use of that particular any different nodes to capture the data and set up your own private gateway to capture and then do it in the applications. Yes,
Right,
that is
right, sir. Right, sir. And sir, have you experimented with the multi-hop communication in LoRa nodes,
um,
sir?
no, I haven't tried, but I'm just evaluating in my present application.
Evaluating in the sense that you are working on it, right?
Yes, yes, sir.
Okay, okay.
So, like, sir, in multi-hop communication, how the communication is done, like from one LoRa node and device to the gateway, and then one gateway to another gateway. What will happen, sir, in multi-hop scenario?
No, don't expect multi-hub communication just like in Zigbee. Zigbee needs multi-hub communication to reach far gateways. But in case of LoRa, the better point here is that the communication range is very pretty good over here. So multi-hub communication is not about hopping the sensor data, but if there is an data correction need to be done. Sometimes when my sensor captures data, there may be error in transmitting the data. So those are the places that we are looking for multi-hub communications in the LoRa protocol. So we generally don't prefer multi-hub communication in LoRa because of the range, pretty good range coverage with respect to LoRa.
And sir, as you have collected the weather data, so sometimes the problem with the sensor is that, like if we are using DS18B20, it stop working after some time, or it is giving constant reading after some time, or if we are using,
that was the problem. Heating issues are there with those sensors.
Yes,
so what we did is that in the microcontroller programming itself, we tried collecting the data and we switched off it for next 30 minutes, and then again we restarted it and then start getting the data. So like that, we tried experimenting on microcontroller to switch on only for every 30 minutes, send the data and go to the sleep mode.
Sir, actually I was
Sir, is there any specific
I was experimented using RA02.
I'm sorry, there was two people. Can you please come again? I'm sorry, sir.
Sir, I was experimented using RA02 SX128 LoRa module.
Right, okay.
Yes, but I achieved in the urban area only 1 kilometer, within 1 kilometer, sir. But I need for our research more than 1 kilometer. Which LoRa module is suitable, sir?
That is what, it's not a problem only with the LoRa node. It is also concerning with the gateway also.
Okay.
So if you have an efficient gateway, then, but those are little costlier. See, for example, in Vellore Institute of Technology, Vellore campus, I am from Chennai campus. In Vellore campus, they have set up, the Vellore campus is close to kilometers in range actually. They have set up two different LoRa nodes. The person who is going to come, Mr. Subramaniam, can throw more light on that. But if you set up over there, it is close to 2 to 3 lakhs cost actually, one gateway itself actually.
Okay.
Those gateways are capable of capturing data kilometers in range actually.
Okay. Thank you, sir.
Sir, which compression method
technology?
If you can go one by one, please.
Yeah. Sir, actually, the person who came from N2 Technology for the LoRaWAN setup module, he told that the gateway and the LoRa nodes, they are having 10 kilometers range in whatever module he has given to us. So I think Mr. Ganesh, he can use our module in the lab itself. He will get the range of 10 kilometers.
Thank you, madam. I was struggling for that one from last 2 months.
Okay. And sir, a question और था sir, is there any like specific format we are getting from the LoRa gateway? Like we are getting the data. So is that data is having some specific format we have to fetch or extract?
No specific format. See, in this case, if I have to project this HDESMAA, it's a base 64 encoded format. That was because the Tata Communications were using that particular encryption to capture the data securely, but it is not that way. You have three secure keys provided when any LoRa setup is being deployed. So if you are aware of those three secure keys that you will define in the header files itself, you'll be able to encrypt the data, decrypt the data properly.
Thank you, sir.
Sir, Manish Bansal this side, sir.
Yeah, please.
Sir, which compression you have used for the data gathering?
This is base 64 encoding. That's what I'm telling. I didn't use that. This was as given by the Tata Communications requirement. So I
Okay.
had to base encode that particular base 64 encoding due to their requirement. There is no such requirement in
Right,
LoRa
right,
to do that.
right, sir. And sir, what is the maximum packet size that you have used in the LoRa communication?
In my case, I hardly use only 6 bytes of data. So 24
6
KB.
bytes.
Yeah, that's it. With respect to all the headers and everything, maximum 24 KB is maximum size that I've tried. But like I have mentioned, it goes till 50 KB size that we can give.
Sir, I think I have read in the documentation that for the data rate greater than data rate of 4, we can have a maximum packet size of 255 bytes. So,
Can you please come again with the data rate? What is that 6 you have mentioned?
data rate greater than 4. Sir, there were 10 data rates that were mentioned into the protocol. So
That is different channels use different
yeah,
data rates. Actually,
yes, sir. Yes, sir. Yes, sir. So for channels greater than 4, we can have a maximum data size of 255 bytes only.
Yes, correct. That is defined by the LoRa protocol. That is
Right.
how Centec will build the protocol's hardware. So there
Yes.
are 10 channels available. One channel dedicatedly available for download, 10 channels dedicatedly available for upload. We can use any of the channels, and based on the data rate requirement and class mode of operation, there are 3 class mode of operation. If you use class 0, which is very efficient, class 2 is actually kind of power hungry. We need always power available there. So based on that, we can define our hardware requirements and then use it.
Sir, can you do the practical demonstrations of these things so that we can learn also that how to set up these things if it is possible? Besides of
Sure,
this,
I can do that definitely. Anyway, Mr. Subramaniam should do it, but just in case participants needs it, organizer can send a separate. You can share my email ID. You can reach out to me. We can connect through Google Meet or any other modem to show the demonstration what I was doing. I'm happy to collaborate on research on those things.
thank you, sir. Thanks a lot, sir.
Sure, sir. Dipen, sir, any other questions? Please see in the chat box.
Any other questions from any of the participants?
Yes, sir. Ma'am, can I ask one question, ma'am?
Yes, please.
Yes, sir. Yes. Can ask.
Yeah. Dr. Bala, sir,
Yeah, please.
thank you so much, sir, for such an informative session. I just have a small query. Sir,
Yeah.
on a edge computing, in a edge computing, like we aggregate data at the edge end. So how we are working on the protection of data on the security? As we know that in the cloud computing, the algorithm and the security aspect are the different way. So on the edge, because we host or we save the data at the local server. So for the security aspects, what is the what we are doing on the algorithm parts, security algorithm part?
See, I have not worked in aspect of security. Okay, my focus is totally on aggregating the data and evaluating an edge model for the IoT deployment scenario, but not on the security perspective. But how I meant the security feature in this particular edge implementation is that my data is local. I'm not taking it out of my black box. My black box holds the data. Okay, as long as your black box is secured and you don't need to put it into through the internet to the cloud or gateway or wherever, so your data is there within your control. So that way I mentioned that the data is more secured with respect to edge computing. Okay, but it doesn't mean that once we prepare an edge model it can run altogether. We would need refinement based on the kind of data that we are aggregating. So sometimes there is a compromise on this particular feature. It depends on the application. Let's say for face detection technology, edge computation works without internet. This is, we have a huge number of models available in internet. You Google, you'll get it. But in the case of my deployment, what I have to do is that every 1 week I send the data to the cloud. I build a new model. The new model gets updated to my particular microcontroller actually, because based on what has happened in the last 1 week, there would be a change in my model that has to be evaluated. Okay, so in that way, I meant the security feature. I'm sorry I couldn't answer you because
No
I
issue.
don't work much on the security feature in edge computing.
Thank you. Thank you so much, sir. Thank you.
Sir, how the
Next.
data validation is done on the aggregated data?
Uh, can you please come again? How the data?
Validation is done on the aggregated data, that the whatever the data we are collecting from a point,
Yeah.
whether it is a correct data or not, how that validation is
See,
done, sir, because
all the data is basically a timestamp data that I am aggregating. I also done a small check on averaging the data that I am aggregating basically. So every period of interval, if there is a wide change happening, I try to discard that particular data and then I try recollecting the data based on that.
right, sir. Thank you, sir.
Okay. Upon the quantity of questions that has been raised to the speaker, the participants have utilized all credit goes to the Bala sir. From the organizing team, I convey our heartfelt thanks to Bala Murugan sir. We were very delighted hearing your research, sir. Now I would request Ganesh sir to present virtual memento as a token of gratitude to Bala sir. So this is a small virtual token of gratitude from our side. And at the same, please, Ganesh sir, please present a certificate as well. So this is a certificate of honor to you, sir.
Thank you. I'm very happy and delighted with respect to the presentation. I mean, received by the participants and the number of questions posed, and which makes any speaker basically to put more energy into the presentations. Basically,
Sure, sir.
the number of questions always. I mean, kind of 20 minutes of questionnaire has gone. I'm very happy to see such a wide reception on my presentation. Thank you, everyone. Basically.
Sir, a special thanks from my side for considering the request and coming for the session, sir. Thank
Thank
you very
you.
much, sir.
Thank you, Dr. Gayatri, for your support.
Thank you, sir.
Yes.
In the future, we will contact you, sir, regarding this.
Sir,
Sure,
can we
sure.
have one photograph? Photograph, Ganesh, sir.
Yes, sir. Yes,
Can
sir.
we have
Yes,
one
madam.
photograph?
Yes, madam.
Sharing option, just kindly
Just
unshare this
unshare.
PPT. Then we can have one.
Stop
Yes.
sharing.
Yes. HOD sir is also there, I think. HOD sir was there.
Manish
All,
sir,
please switch
join.
on the videos.
Manish sir, Jitendra sir, please join. Join for photograph. Thank you, sir.
Okay. Can we have photograph now?
Yes, ma'am. You can take.
Smile, please. Okay. Thank you. Thank you.
Thank you, sir.
Thank you, sir. Thank you very much.
Thank you,
Thank
sir.
you, organizers. Thank you,
Thank you, sir.
participants.
Thank you, sir.
Thank you.
Next session will start. Next session will start after the 5 minutes break.
Okay.
भैया हेलो ड्राइविंग कहाँ पे फिक्सेशन कितना बजे स्टार्ट करना है ये नहीं आया नहीं मैं बोला है 5 मिनट्स बोला है
It's earthquake. Earthquake आ रहा है.
Earthquake आ रहा है, vibrations आ रहे हैं.
हाँ earthquake आ रहा है.
और
Good evening, Vidyadhar sir.
hi, good evening, good evening.
Good evening. We'll be starting in 5 minutes.
Good evening,
If you give
sir.
permission. Yeah.
No problem.
बताओ भैया हाँ 5 मिनट मैं 5 मिनट बोला था
I think you're on mute if in case you're speaking, Dipendra, Mr. Dipendra.
No, sir, I was on call.
Okay, okay, sure.
So actually, we had our last session finished at 8.
Okay.
So we have given 5 minutes break to the participants.
No
so
problem.
that
You want me to
we can
join after 5 minutes, or it's okay? I'll be waiting for you
uh,
to start.
It's your wish, sir. You could be here.
Okay, no problem.
Okay, Ganesha, should we start?
Yes, sir. You can
Yes, sir.
start.
You can start, sir.
Okay, a very good evening to everyone, and I extend my heartily welcome to Vidyadhar sir. So we heartily welcome you to the day 4, session 2 of the 2-week ATAL FDP on integration of WSN and IoT for agriculture.
Thank you, sir.
A brief profile, Ganesha. Sir Vidyadhar Jinnapaski received his BE in Electronics and Communication from Vishwesvaraya Technological University, Belgavi, Karnataka in 2013. He holds 2 master degrees in the field of Embedded System and Instrumentation from Mahe, Manipal, and Control and Embedded Instrumentation from SL Gelec, France. He is currently working as Head of Emerging Technology COE at Mahindra and Mahindra Group Technology Office, Mumbai. He is responsible for architecting, implementing, and deploying R&D use cases in industrial IoT, industrial 4.0, and manufacturing 4.0 areas powered by machine vision, deep learning, and data modeling techniques. Before joining Mahindra and Mahindra, he was working as an assistant professor in the Department of Computer and Communication Engineering of Manipal University, Jaipur. He had also worked as a research associate in ABB Corporate Research Center, Germany, for 2 years. His research interests include, but not limited to, data science, IoT in healthcare, industrial IoT, computer network, and wireless sensor networks. His work has been published in index journals and conferences of international repute. We are delighted today, sir, to welcome you and to hear from your experiences. Uh, and I would request every participant in this group to kindly utilize this lecture or the session from Vidyadhar sir. So I would hand over Vidyadhar sir to you.
Yeah, sure. Thank you, Dipendra sir, for giving such a wonderful introduction about my background. So I hope I'm audible loud and clear to all of you.
Yes,
right?
sir. Yes,
Sir,
sir.
yes, sir.
Great. So I'm going to share my screen now. Let me know if you are able to
You can
see
share,
it.
sir.
Yeah. Is it visible?
Not right now, sir.
That will take.
Okay. Give me a moment.
You click on present now, sir. Present.
Yeah.
Yes, sir, it is.
I hope now it is visible, right?
Yes, sir. Visible.
Yeah,
Sir.
Okay. So, yeah. First of all, I would like to congratulate the whole organizing committee of this wonderful faculty development program. So it is, I think, the applications of wireless sensor networks and IoT in the field of agriculture.
Yes.
So I was supposed to speak on WSN as well as IoT in agri, but somehow most of my experience has been with Industry 4.1, 5.2. So I thought let's make it in maybe IoT and wireless sensor network still remains same, but the applicability will be somehow inclined towards more of a Industry 4.1, 5.0. So I'll be speaking in today's session on a topic called role of modern technologies in manufacturing industry, right? So so I think sir has already explained what I do as a head of emerging technology COE, but let me also give you a brief overview of what we as a company do over here is. So I work for Mahindra. Basically, we are a group technology office. So at Group Technology Office, we do take care of implementing in-house technological solutions across our 22 plus businesses. So as you might have known about Mahindra, so it's just not in the field of manufacturing auto and farm equipment. It is also spreaded across multiple other verticals, including finance, including your real estate, and also the holidays, right? and also service groups. Okay, so all these subsidiaries are centered, like this group technology office will provide the technological implementation to those 22 plus subsidiaries by using modern technologies, right? So as part of emerging technology, I do work in IoT, computer vision, AI, ML, and data science. So mostly my expertise is to deal with manufacturing facilities. So I do take in-house implementation projects related to manufacturing facilities, right? So what I'm going to give is to give you a brief on what Mahindra as a company does, and how do we operate in group technology office, and what are our driving forces. So at Mahindra, these are the brand pillars. We don't accept limits, and of course, nowadays everyone have started thinking parallelly with respect to traditional approaches. Alternative thinking is one of the force for Mahindra, and we do drive positive changes across our businesses. So these core pillars are supported by various professional core values, including professionalism, good corporate citizenship, customer first approach, and quality focus, right? And no fault forward approach. Also, the dignity of individual, right? Okay, so I am going to, like, this topic is mostly about Industry 4.0 in manufacturing facility. So I'm going to take you through a video which is 1.5 minutes length, and in there I would be especially taking you through how the vehicle is being made, start from press shop till to the assembly line, right? So the metal sheet will come, and then there'll be a press shop which will certainly cut down those metallic coils into a vehicle sheets, and then there are certain procedures involved so that it's take a shape of vehicle. So let me play a video and let me know if you are not able to hear the audio. I hope the audio is audible.
Audible.
Okay, perfect. So this was how the Scorpio N is being made. So this was one of the state modern facility for manufacturing sports utility vehicles that we do have in India, and of course it's one of the largest facility across the nation. So it has been spreaded across more than 750 acres of land, and around 27 plus shop floors are there, right? And so as you might have seen in the video, like it's not traditional way that we are employing for manufacturing vehicle. It's like, how you digitally transform a industry so that, you get more productivity in terms of, rolling out more number of vehicles per day. So right now we are able to manufacturing 250,000 per quarter of these vehicles. But over the period of 2 years, we have a target to increase this 250,000 to 500,000 vehicles per year, right? So this has been possible only when we do, take care of small scale problems which we find across the assembly line in terms of optimizing the speed of the conveyor belt and also automating the processes that we come across in the conveyor belt, right? So that was about that video. Like you might have seen that there's very minimal human intervention in the process of manufacturing these advanced SUV vehicles, right? And so at Mahindra Digital Engine, so earlier we used to call by the name of Mahindra IT, but recently we've changed our nomenclature from Mahindra IT to Mahindra Digital Engine, right? So engine because we do drive the whole of a business, right? And the objectives are innovate, transform, and grow with the businesses. So again, I'm going to take you through one more video. So we recently launched a MADE, which is Mahindra Advanced Design Europe Center, wherein all this electric vehicles are being researched and they are being designed. So recently we launched a vehicle called XUV400, which was a marvelous of including both hybrid and modern day technologies. So that was designed in MADE. Also, MADE is responsible for designing the F1 racer cars, right? So, and also we are by 2040 we are having a hope of going for a carbon neutral facilities. I mean, we are removing all those petrol and diesel engines and only going to be with the electric sector.
Can the most disruptive electric vehicle be Indian? Can it also be global?
Some say we're in Mumbai, others Turin, or even Oxfordshire. We just say we're global.
Can an electric vehicle have history, but also be futuristic? Can it be serious and fun? Can it be exhilarating on the racetrack, yet ethical on the road? Can an EV support an unplugged, yet plugged-in lifestyle? Quieter, and yet more dramatic.
These are the questions we're solving for tomorrow. And at Mahindra Design, we love asking questions. We are building an original design philosophy that will challenge conventions. A design philosophy born from a racing spirit. If we stop asking questions, we stop moving forward. We can be sure that the future will be electrifying. And we're excited to have you join us on this electric journey.
Mahindra, we are putting sport back into electric SUVs.
Yeah, so this was a Born Electric which we recently inaugurated. It's one of the visions. Like as I said, by 2040 we wanted to go carbon neutral manufacturing facilities, right? So we will not be having any petrol or diesel engines by 2040. All of our vehicles will be of electric segment, right? What we do apart from just dealing with manufacturing facility at GTO is also support other verticals, right? So as I said, there are 22 plus sectors of businesses that we operate in, including aerospace and then aftermarket services, agri industries, right? Auto and farm equipment businesses, right? Boat manufacturing, clean energy, and so on and so forth. At GTO, we have various verticals over here, right from board of architecture, then the shared CIO, wherein multiple other businesses are all information is being centrally exchanged with. and we have technology service groups which takes care of the implementation of these underlying infrastructures such as internet and the intranet. Then there is emerging technology COE, which is being currently headed by me, and we also have Cloud Center of Excellence. As part of this program, we've recently launched all our SAP services into cloud. So now we don't have any on-prem server computation units. So all of our on-prem server compute instances are being moved to cloud, right? And apart from everything, we have enterprise applications. So this is where an application at enterprise level is being architected. All right. So that was about Mahindra and Mahindra, friends. Now I will take you through a little bit of IoT, and then we'll also speak about how the industry was evolved from industry 1.0 all the way from 1.0 to 4.0, and then we go for use cases, right? So what I'm planning for this presentation is I've made some use cases which I would like to discuss with you, which were basically R&D based use cases which we recently implemented across our various facilities, right? In the year of 1999, there was a scientist called Kevin Ashton. He, invented a term called Internet of Things. That was a special interest group. I think it was a conference held in Germany. So from there onwards, Internet of Things has been come in the market. So in the year of 2000, LG was planned to make a internet-enabled refrigerator, right? And in the year of 2002, there was a company called NeighborStack who has done this little robot made. So that was used to spell out the stock market related information, which was IoT based. Okay. And in the year of 2006, during the first European IoT conference, they have launched something called IPS. So it was an organization, Internet Protocol for Smart Object. And so it governs all the protocol related activities. So what protocols to be made available within the market, what protocols, and what should be the governance body of these protocols, right? And in the year of 2008, US Intelligence Council declares IoT as one of the emerging technologies, disruptive technologies, apart from what we have out there like AI, ML, and the data science, right? So this is how IoT evolved. Like this picture itself is very informative in the nature. Like in the year of 2003, this was a Cisco survey which got published in the year of 2018, by the way. In the year of 2003, for the world population of 6.3 billion, there were around 500 billion connected devices. Like, each person was hardly having any device back in 2003. But when you compare it with the current scenario, it was predicted in the year of 2020, if for the predicted population of 7.6 billion, there will be around 50 billion connected devices will be there. Therefore, each person is having more than 6 devices with him. I myself have, I think, 7 to 8 devices. So when I say connected device, by saying connected device, what I mean is maybe your Apple Watch, your connected, smartwatch, your phone, tablet, personal digital assistants, laptop, right? Whatever that can be brought into the internet is a connected device, right? So you could just count how many devices you have and how abruptly the intervention of such IoT have come into the daily life and also improving the productivity of a human life, right? In my opinion, how do I define IoT is basically we've all thought and spoke a lot about 2D infrastructure, right? So back in 2000, we used to have these telephones, wired telephones, and which used to facilitate with anywhere connection to anytime connection. So to already existing 2D infrastructure, so IoT had added another benefit or another vertical called anything connection, right? So in IoT, any physical object which has a physical existence can be brought into the network by just giving some unique addresses. Maybe these unique addresses can be derived from you have this IPv4 protocols and then IPv6 protocols, right? So that's how we can define IoT is a third dimension for already existing 2D infrastructure, which was anywhere can be connected to the. So this was basically published in one of my research articles. Like I've tried to visualize IoT with respect to your TCP/IP protocol or OSI model for that matter, right? So it's a layered approach. Of course, here also you see different layers. Like we see physical data link, transport, network, application, presentation, and session, right, in OSI model. So similarly in IoT also we can visualize the whole paradigm of IoT with respect to different layers. Start from object layer till to the business layer, right? The object layer consisting of all your sensors, microcontrollers, all those devices, right? All those physical entities which are being tried to brought into the network domain, right? And then we have transmission layer. Of course, the sensors are data acquisition system. Once the data is being acquired, it has to be sent for processing or gaining insights. And therefore, transmission layer is something which takes care of transferring data from physical layer to the cloud. All right. And then application layer will basically give you the application access to users for looking at maybe your monitoring applications, your visualization applications, right? And apart from all these layers, there's something called business layers, which sits on top of all these layers, which will gain some business insights, maybe to improvise their business models through flowcharts, graphs, and predictive maintenance kind of a thing. So that can be done in business layers. Just stop me whenever you have questions. I just don't want to, keep on speaking monotonously. Right. So these are the enabling technologies that we do have for IoT domain, right? So I tried to categorize with respect to different classes, sensors and actuators, gateways and wireless protocols, wireless modules, and then protocols, processing units, then the cloud platform, right? So sensors are those devices which are used to transfer, basically they are the transducers, right? So they convert one form of energy to another form, maybe a physical form of energy to the electric form. And you can sense any instance which has some physical measurables, okay? And so I tried to give some examples over here: EEG, ECG, EMG. These are medical sensors, of course. And we have biometric temperature sensors, barometric pressure sensors, right? And then accelerometers, and then air quality sensors. Some of the examples. And speaking about gateways, these are most widely used gateways across IoT application implementations. They are low-range IoT protocol, network address translators, small area networks, and hybrid area network, and also human area network is there. Nowadays, it's a bloom now. Basically, it's been used widely in medical field, which we call it as human area network. Right? Those patch cords, which are maybe they can be attached on the body, and then they try to extract some of the biometric parameters from the human body, right? And also the 6LoWPAN, which is a low lightweight protocol which supports IPv6 addressing space. And speaking about wireless modules, we all know that these are the existing wireless modules. Apart from this, we do have also existing the low Bluetooth energy. It is one of the, and also the active RFID. So low Bluetooth energy and active RFID are the recent inventions, and they are widely being used for transferring data in a local, basically with wherever the operational range is limited from 5 meters to 21 meter, and then these kind of protocols can be used right there. And coming to protocols, of course, these data needed to be handled systematically, and we have standard protocols for dealing with these data, right? So, for example, constrained application layer protocol, message queuing transfer protocol, hypertext transfer protocol with secured access, advanced message queuing protocol, right? And XML-based message protocols. So these are some of the protocols. And processing units, depending on the application, we choose microprocessors. Right? They are 16-bit, 32-bit, and sometimes 64-bit also. There's a JVR kit, right? So Jetson JVR kit, which comes up with 64-bit power, data processing capability, right? Arduino, Raspberry Pi, Intel Galileo, Intel Edison, so on and so forth. And yeah, so some of the cloud platforms in the rightmost side, AWS.
Sir, are we connected? Vidyadhar sir?
I think maybe
Yeah.
Welcome, Dr. Rajiv Sakhya. Good evening, sir.
Good evening, sir.
You cannot directly interface it with any microcontroller. What we are seeing is, how are we mapping the physical entity to the?
Vidyadhar sir, we are not able to see your screen, sir. I guess.
Is it?
The screen share has been stopped.
Okay, it was just stopped or like how?
Just now stopped.
Okay.
Yes.
Just let me re-share again. Is it shared now?
Yes, sir. Now it is presenting.
Okay. All right. So I am at a slide of how a sensor works. Is it visible?
Yes, sir. Visible.
Yeah. Okay. Perfect. So So what I was trying to say is how a physical measurable force can be converted to a form wherein your microprocessor is able to read it as a data, right? So in the left hand side, it's calibration circuit. In the right hand side, it is the conditioning circuit, right? So we kind of it's basically a infinite resistance when it is not connected to any closed loop circuit. It is it's having the infinite resistance. When you connect it in a closed loop and you apply some force, the resistivity goes down. As in when the resistivity goes down, the conduction increases, and therefore mapping of these resistivity with respect to current conductance is what we call the calibration. The calibration is needed very much for analog sensors in order to see how much force is being applied, especially for this particular force sensitive resistor. All right, so these are various application domains where IoT can be used, right from smart home, assisted living, healthcare, smart environment, education, transport, and of course in industry in the form of IoT, Industry 4.0, right? So how did we start evolving the industry all the way from 1.0 to 4.0? This particular slide will give us more insights on that particular topic, right? So back in 18th century, it was all a mechanical production, which was supported by energy called steam, right? And then when we started evolving things out, then we had come to Industry 2.0, where the mass production was supported by something called electrical energy, right? And in the mid of 20th century, somewhere between, I think there was a scientist called Henry Ford, who was the founder of Ford Motors. He invented something called the assembly line, right? So, or the conveyor belt. So this is a time where Industry 2.0 has been taken a shape of proper compute facility, and that's when they've implemented PLC, programmable logical controllers. And we first introduced computer within the manufacturing industries. That was the era of somewhere between 1950 to 1960, and we call it as Industry 3.0. And 4.0 is basically, since computer was introduced for manufacturing, and then how about connecting those industrial equipment, providing a platform so that they can talk to each other, right? So that's what Industry 4.0 does, right? So it derives certain intelligent information through sensors and actuators and the processors from the assembly line or from the conveyor belt, in order to support business for improving the productivity. So that's what we do in 4.0. So nowadays people have started talking about industry 5.0. It's basically a transition from introducing those modern technologies such as IoT and data science in the industry to correlate that with the person. So now in industry 5.0, so the data from person is also being retrieved, and it is being used for making certain intelligent decisions, right? So this is all about industrial evolution from 1.0 to 5.0. Right? All right. So now I'm going to speak to you with certain use cases that we had designed in-house, right, for solving some of the industry problems, which falls under the category of Industry 4.0, right? And the first one is adding computation and communicational capabilities to existing product, right? So there was a motor called, this is advanced shaft motor. So this is basically used to drive the assembly lines, right? And we are importing this from ABB. So this comes from Germany. And there was a lot of problem in the logistics part of shipping this from manufacturing facility of German, like ABB, to our Mahindra unit. By the time it reaches, like most of the parts were sometimes not working, or it was got dents, and the circuit got broken because it has a lot of delicate circuits within it, right? So it basically is like your stepper motor only. So it rotates with a step size of 1.8 degree. And then in consultation with ABB research team, we try to design a smart glue, which is basically used to attach it with this particular device once it is being transported from their manufacturing unit. Okay. So then the question comes here is, IoT is beneficial in terms of you can use it as a plug and play device. You don't have to consider the whole device as a redesign strategy, or you don't have to redesign or re-architect the structural part of this particular device. You can just use a plug and play device. You can put whatever the sensors or processing units you want to do and you want to capture from this particular unit. You can use it as a smart glue, and therefore data starts transmitting from this device to the cloud, wherein you can analyze what is happening with the shipment of this particular motor from ABB to Mahindra. Okay. So there were certainly challenges, right? Creating a smart device on existing product. So we don't have to consider redesigning the whole motor again, right? So it will be a plug and play device. And also we needed to experiment it in order to see whether it is able to work as per the expectations or not. So this is the smart glue that we made with the help of ABB. And so in there we have various sensors incorporated, GPS sensors to track the location. Sometimes these drivers will take they're supposed to come from X to Y, and they will take some other route in order to save the toll tax or something, and therefore those routes are not preferable. And this was also one of the reasons why these motors were delivered corrupted and at the units. So we thought of adding GPS sensors, then the scanners, then the temperature sensor, and then the vibration sensors, then attach it. And once it has been attached, so there will be a MQTT services which are being called from the cloud, which will basically exchange data from this particular hardware device to our Industry 4.0 service system, right? So in the prototyping phase, it was existing product plus smart glue, and in the implementation phase, so we've recommended ABB to give us this as an integral part of this device only, right? So again, there was a factory automation system. We worked on a real-time observer project. So like you can see, all the robots that we use in our Chakan plants are supported from ABB, by the way. And as you can see, there's this pick and place robot, this is factory automation system is a corporate research centers. What do you say? The simulation unit of the assembly line, right? So whatever happens on the assembly line is being simulated in this factory automation system, right? So there are different types of sensors which are used. Like you can see in the leftmost figure, there is a robotic arm which is basically picks the object and place it onto the assembly line, right? And while doing so, the cable, you might have seen there is a blue cable which is coming from the upside along with the robotic arm. It's basically getting, it's getting broken for no reasons, right? Because of the tension changes or because of the temperature variations within the shop floors. So that used to get broken. In order to address this, we've added certain flexibility sensors and tension monitoring sensors. And likewise, we've added some other sensors, temperature sensor, and also the the vibration sensors. And in order to visualize this in real time, there's something called Google Glass, right? So what this glass is, it's basically an Android supported glass. Is it again gone? Is my screen visible, right?
No, it is visible, sir. Visible.
Okay. So you just wear this glass and all the sensors are already in place. Like you can see in the leftmost place, like temperature sensor, vibration sensor, and the camera is there, right? And the tension sensor is there, and they are being interfaced with the Raspberry Pi. And Raspberry Pi is supported with internet protocols, and the data is being transferred directly to the cloud, right? So Kairos database is a time series database, which is used for taking data in real time. Only the time stamp and the associated sensor value. So that's the beauty of this Kairos DB. See, in other structured databases, we have tables and it's a complicated database, right? So, but Kairos database is very much preferable if you have time series data to be stored somewhere in the cloud. Okay, so we've transferred all the data in cloud, and there's a Google Glass, which supports Android SDK, and you wear this glass, and it basically has a lens. Which is basically looks like a mobile screen only. Like you are going to just above your eyesight, you're going to see the entire screen, and there are certain sensors incorporated in the right hand side. As you can see, there is a QR code reader, there's a camera, and there's a microphone, there's a speaker, right? Everything is there in this particular device. And you look at the QR code, which is affixed to this particular setup, which we call it as FAS 4.0. And you are going to see all the data in real time. What is the health of this particular tension sensor? What is the temperature? And where exactly are you located, right? So in shop floors, what happens? Oftentimes, for visitors like fresh visitors, they don't know where exactly they are there, right? And they want to know within the shop plan or within the entire plan, where exactly they are located, right? So this indoor positioning system will very much be effective in terms of identifying them within the whole manufacturing unit, right? And how it works is there are Wi-Fi access points which we have deployed across all shop floors, and each Wi-Fi access point is uniquely identified by its SSID, right? And whichever because this has a Wi-Fi reader, this Google Glass has a Wi-Fi reader signal. It basically reads the signal strength of the Wi-Fi access point, and whichever is the nearest access point is going to give you the highest strength, right? And therefore you can map that with respect to location. So along with all the sensor data, you can see the data in real time, like your location data apart from sensor data, so that so this particular sensor is working fine, right? If there is any variations in the threshold values, those values are tweeted in the red or some orange colors. Then you can manually go down to that particular shop floor or that particular unit. You can see what is wrong with it. Okay, so this is kind of a predictive maintenance approach for which is being used for industrial automation, right? So this is the technical specifications about Google Glass. It has a battery life of 1 or sometimes even less than 1 day, right? And it has got a 5 megapixel camera with 720 pixel support, and there's a touchpad also. Right hand side, you can see there is a touch area, right? And display of the size 640 cross 360 pixels. It supports Wi-Fi and Bluetooth and has an internal memory of 16 GB. Also, it has eye tracker sensors and microphones. And just like your mobile device, all that you can do in mobile can be done in a device like Google Glass. All right. So using such applications, we can observe the real-time data of industry, right? And what benefits we get out of such applications is increase the awareness on understanding the implications of current information. And of course, once we are able to see it in real time, dynamic control of industry is possible, and resource utilization ratio is improved drastically, right? Like for example, any particular equipment is underutilized, you will get to see in the analytics part, and you can probably take decisive actions in order to replace or in order to widen the scope of that particular device, right? And it all provides reusable infrastructure for predictive maintenance. And I mean, data can be used for multiple analysis. It is just not about predictive maintenance. It might sometimes also give you the real-time analysis. It might give you some real-time insights about the industrial operations. Right. Yeah, so this is another project which we have done and implemented in one of our tractor manufacturing units. Right. So it was done in Jaipur. Right. So oftentimes what happens, so in Pune, I said that we've seen in the video also, this is all state-of-the-art modern facility, but in some of the other, like, when you come to Mumbai, there's a Mahindra plant which is 70 years old, right? Suppose there we have stopped even manufacturing farm equipment or farm vehicles, right, like tractors and all. But some of the facilities like in Jaipur, they are not modern plants, they are traditional plants, okay? So there still we have a lot of operators, workmen and then laborers who are manually supporting the process of these tractors being manufactured. Okay, so the problem over here was, these are the stickers, like you can see Mahindra 475 DI MSXP. These we call decal stickers, and these are the basically they say something about what is the model number of the tractor, what version is it, what version of the engine is it, right? And there's a Bhumiputra stickers. So workmen oftenly they are printing, like for example, if any particular tractor is supposed to be pasted by a 5-year warranty sticker card, but somehow by mistakenly workman has pasted a 6-year warranty card, and it has gone dispatched to the distributor, and even it is with the customer. So the customer thinks that it is 6-year warranty, whereas it is actually entitled for 5-year warranty, right? So this was a big problem of branding as well. So Mahindra as a brand, it maintains its decorum of good customer relationship. But when such things happens, it will definitely affect negatively on the brand. So therefore, what we thought was to implement a computer vision based solution in order to address this. So we've tried to fix multiple cameras across the assembly line, right? And you capture the images, and the images are being compared. And like for example, if you first able to read what is the vehicle identification number, or what we call is VIN number, right? And in the display, you're going to see, okay, so this is the VIN number, and these are the stickers to be pasted on the that particular tractor. But somehow these stickers are not pasted because that has been identified by my computer vision system. And then and there only, the workman will get an alert saying that, okay, so this sticker has been wrongly pasted. 6-year warranty would have not been pasted. Maybe he can take some corrective measures as in when he detects this some erroneous affixment. Okay. So this is the overall architecture for decal verification, project. So there's a camera which continuously streams the images into the cloud. And of course, you need to identify these stickers, right? So we need to train the model first. It's called pre-trained model. And so that, basically there's something called OCR, optical character recognition technique, which will extract the text out of those stickers and identifies and compares it with the right sticker to be pasted, and therefore you'll be able to see whether the pasted sticker is correct or not, right? So then the corrective measures can be taken accordingly. So the next project was vehicle tracking at MRV. So this was Mahindra Research Valley, Chennai. So the problem over here was, we've done. So as you can see in the mouse pointer is locating, these are the RFID readers, and these are checkout readers. Likewise, check-in readers are also there in the opposite side of these two readers. As and when vehicle comes in, the vehicles are equipped with the RFID tags, and it gets registered. But somehow, once there are multiple vehicles coming in, then there is a possibility of tailgating, right? So your two readers are not, check-in readers are not able to read the entry of a new vehicle or entry of a parallel vehicle, where the count of the vehicle is 2, but in your RFID the count is only 1, right? So to address this problem, we had fixed the camera over again here. So we use something called automatic number plate recognition system, APNR, right? ANPR, sorry. Then what happens over here is, so as and when the RFID reader reads the data, and it basically triggers an API, which is basically from RFID server to the computer vision server. Computer vision application is running in Jetson server, right? And for every entry of vehicle, okay, so the count value is now 1, and computer vision has also captured the vehicle count value as 1. There is no difference, right? And therefore there is no alert email triggers. Whereas count value in RFID is still 1, whereas count value in computer vision system is 2, because computer vision is basically placed in such a strategic location. It's basically able to capture all the vehicles who are coming in and going out. Okay, so then the count mismatch is there. So as and when there's a count mismatch, the Jetson triggers an API which will basically capture the screenshot, or it will capture the image of the vehicle, as you can see over here. And this particular, the number plate is also being retrieved, and the email is being sent out to the security notice, security people, saying that there is a trespassing detected. Okay, so that way the security people will be alert on the trespassed vehicles, right? So there are multiple API are being used. One is post image API, which is called from Jetson Nano in order to transfer the image captured from the computer vision to the security people through email server, and then the reset count API. So as and when the Jetson Nano powered off, so this reset current count API gets triggered, and it will basically restart the Jetson Nano operation. All right. So coming back to the other use case, basically we've also worked on access control mechanism. We try to give the because oftentimes what happens in some critical shop floors, right, where the welding is being done, especially. Recently there was an incident that it picked up a person. Like there are some suction robots which are basically supposed to pick up the glass, right, in the assembly line. But somehow there was, in that particular robotic cell, there was a person standing, and it picked up him and it threw him. Somehow that person got injured, and therefore we thought of implementing a access control mechanism for critically operated areas, like robotic cells was one of the examples. And then what are the approaches? So we've had multiple approaches. One was role-based approach, then the attribute-based access control approach, then the capability-based access control approach, right? So role-based and attribute-based are somehow, using centralized approaches, which was very limited for such dynamic use cases. Therefore, we've gone for capability-based access control, wherein the access rights are basically assigned to something called capability token, which is centrally generated. And this token is signed centrally, and it's not forgeable. And once the user gets this token, he will be given access. So this is the block diagram of that particular access control mechanism. As and when if the user wants to have an access to that particular door, he will basically use certain credentials in order to open it, and the credentials are just to give him the first layer access. And in the first layer access, his legitimacy is being checked, whether the user is blacklisted user or he is some unauthorized user or authorized user. So the context is being embedded in this particular stage, and once the contexts are being embedded, we have the policy descriptors and responsibilities and permission dispensers. These are the data stores basically. Depending on the access level, the particular person will get access. Okay, so then there will be a token generated, and all these responsibilities are attached with that token, and that has been centrally signed. And user will receive the centrally signed token, and he'll be now entering that centrally signed token. And once this has been verified, because centrally signed token is stored somewhere else in the cloud, and the user will enter the same token, and then it basically there's a match, and then he or she will be given access to resources or access to the doors. Right? All right, so we've been talking about using IoT in industry, right? But energy optimization is one such area wherein a lot of research is being done, right? So most popular approaches are cluster-based approach is one of the popular approaches, wherein instead of you basically make clusters out of these nodes, and instead of assigning trans-reception capabilities to all the nodes, there'll be one cluster head who is going to take the responsibility of transferring data from that cluster to the base station, right? And that way we can optimally utilize the power supply, and therefore it can be used as one of the energy optimization techniques. So next one is scheduling approach. So we are going to schedule these clusters with respect to time period. Like for example, cluster 1 is supposed to transfer data during time period T1. And so these are only preferable when the real-time data is not needed. Like if your application is real-time sensitive, then this is not preferable. Right? If in case the real-time sensitivity is less, we can use certain such approaches. Wherein scheduling approach, basically clusters are nominated with respect to different time periods, and therefore during those time periods they are being transferred data to the cloud or wherever the data is being processed. So this is one of my last slides, which is basically I think needed if you are an IoT developer, because most of the time we get a question which microcontroller to choose, right? So depending on the criticality, depending on the certain research questionnaires, right, we will find a better answer for which particular microcontroller to use, right? Maybe a performance. Then if it is performance centric, then we have certain dedicated processors such as Jetson Nano Xavier kit and Jetson Nano evaluation kit, right? And if it is a miniaturized, like whereas the space is a concern, then we certainly have Pro Mini, and where the miniaturized processors are available. But it all depends on what is the application type and what is your approach to address this problem. Is it having any critical real-time sensitive application, or it is just the normal application, right? So yes, that's all for this session. Now, thank you so much for your patience, and if you have any questions, I'm open to take your questions.
Okay, the session is open for the questionnaire round, so I would request the participants to kindly clear their queries if they have.
Sir, I have one question. I am Ganesh here.
Yeah, Dinesh.
Can you tell me about what you mentioned that Kyrios DB?
Yes,
all
yes.
the time series. Can you
Yes,
tell me
yes.
out clearly?
So Kairos database is basically a time series database, right? So let's say, for example, you want to store in healthcare application, what happens? You want to store time series data, like for example, day day
Sensor
one,
data.
certain sensors are being given to the patient, and he want to basically these are wearable devices, right?
Yes.
And he will be wearing them periodically, or he will be wearing them all the time.
Yes.
And doctor is not interested in learning anything about that person, but he only wants to learn about what was his parameter, let's say body temperature. What was the body temperature from time morning 9 a.m. to 6 p.m., right? So there's a lot of data involved. You cannot use a structured database for storing this real-time data, right? So because in structured data, what happens, you'll have to make a table, and then table header is there, then there are certain key parameters to identify that table in across the database. So in those cases, especially when the real-time data is to be transferred over the cloud or any databases which are remotely accessed, we use Kairos database. There are multiple Cassandra-based databases are also available which support real-time data transmission.
Thank you, sir. Thank you.
Yeah, sir. Namaskar. This is Sonu.
Yeah. Hi. Namaskar.
Sir, actually, I'm having one question. How, sir, biomedical sensors like electroencephalography, EEG sensors are working, sir?
Biomedical?
Sensor, sir. Biomedical sensor like EEG, electroencephalogram.
Okay. Electroencephalogram. So this is basically, electroencephalogram is used for tracking the brain activity. Okay. So, sensors are those devices which have some characteristics changed as and when they're exposed to certain energies, right? So like I said, I've given you one example of force sensitive resistor, which changes its characteristic. What is the characteristic? Characteristic is the resistance, right? So when you apply certain force on the sensing area, the resistance of that particular sensor decreases, right? Initially, it was having the infinite resistance. As and when you apply force on it, it reduces its resistance, and therefore, with the reduction resistance, you could map that reduction in resistance with respect to the current conductance. Okay. So similarly, in electroencephalogram, it's a capacitive sensor. The capacitance of the particular sensor varies with respect to various brain activities, right? So they are so sensitive. These sensors are so sensitive, they are even able to capture the variations of a brain and then change certain parameters, and then accordingly you can calibrate. Okay, so if this is the recorded graph, or if this is the recorded observation of that particular sensor, and this is the mood, right? So angry, happy, sad. So accordingly, you are going to get different output from these sensors.
Okay, actually, sir, this is also used for recognizing some brain activity like alpha, beta, gamma, delta.
Correct.
So, sir, how can I? Actually, I'm working on this research area only, sir.
Okay.
Sir, how I can think some alpha type of frequency range I got from the particular range of.
Sonuji, I haven't specifically worked on these sensors, but if you want me to give you some information, you can basically be in touch with me. I have a professor who is working, because my research area was basically access control mechanism, especially for accessing healthcare devices, right?
Okay, sir. Okay.
So if you want me to connect a professor, or you want me to discuss after this class, we can do that. Like, you can contact me with your details. I will give you maybe if you want to access lab facilities also.
That's my pleasure, sir. Definitely, sir. That will be better for me.
Sure.
Yeah. Good evening, sir.
Thank you so much.
Yeah. Good evening, Ranjan, sir.
Yes, sir. Sir, I may be querying that the same process what you have explained is adopted in the ECG and EEG.
Yes.
Techniques. Okay. Yes.
Correct.
Okay, sir. Thank you.
Thank you.
Good evening, sir. Sir, I have a question.
Yes, please.
Sir, if we want to construct or we want to make a device, health monitoring device, so various types of sensors are being calibrated on one microcontroller board. So how can we decide that which microcontroller board is compatible with which type of physiological sensor or biosensor?
Yeah. So, like for example, if you take a simple biomedical temperature sensor, right, and also ECG sensor, right. So,
Yes.
wherein you also have to think of, if you are creating a biomedical device, so the ease of usability, like if it is given to a patient, how he or she is going to use it, right? So that user friendliness, right? First of all, it has to be miniaturized. The processing unit has to be miniaturized. You cannot keep a whole of a microprocessor like that's the nano board over there, because there you're just analyzing the electro, bodily signals such as ECG and the body temperature. So there you can probably think of using miniaturized microprocessors such as Pro Mini and Blue Mini, right? So Arduino has these boards, and just for interfacing you can use it. And if you want to add certain capabilities, like you want to transfer this data to a cloud or somewhere, you first have to give the internet connection, right? So Arduino doesn't come up with the internet connection. So what are the available options? We have the ESP8266. You might have heard about it, right? So that's basically a Wi-Fi extension which can be used with any controllers like Arduino, and then you can transfer the data to cloud. So it basically gives you Wi-Fi visibility, and you have Wi-Fi at home, and your device is connected to Wi-Fi. Therefore, you can transfer data to the cloud.
Sir, there are various Arduino boards like Nano, Mega, and Uno. So, which one is compatible? How can we decide this?
Again, so these are all 16-bit microcontrollers, right? So if the data transferring is a matter of concern, like you want to really transfer data without any loss, you want to transfer it into the cloud. So what is your application? It all depends on what is your application and what data transmission rate you want. That is what we call bandwidth or baud rate. Okay.
Yes, sir. Yes.
So it all depends on really what application you're working with.
Okay. Okay. Thank you, sir. Thank you.
Thank you.
Hi, sir. This is Manish Bansal from IIT Delhi.
Hi, Manish.
Sir, how do you ensure the security of the communication that is being happening in industrial IoT settings? As you were mentioning about the node MCU, they are vulnerable to Byzantine attacks or man-in-the-middle attacks.
Correct.
Modification. So, how the security can be ensured?
Security comes in when you are trying to put data on cloud, right?
No, sir. Not in that way. If let's say if there are two devices are installed and there is a gateway, I can send malicious data to the gateway by registering with the gateway. So if I am sending the malicious data through that, any mishap or any kind of thing can be done on that thing, because the decision will be taken on the basis of the data being received by the gateway node. So how the security will be ensured in this setting?
Can you give me more insights on what are the physical layer devices you're using?
Physical layer devices, I'm using Node MCU, Zigbee, LoRa modules.
Okay.
Yes, sir.
So you want to transfer this to across the network or within the on-prem servers?
Sir, within inside our private network only.
Okay. So you want to transfer data securely, right?
Yeah.
So I think Manish ji, so we have MQTT, right? MQ by message queue.
Yes, sir. Yes, sir. MQ.
Have you used that?
Yes, sir. For LoRa node MCUs, we have to use MQTT only for subscribe. And
so in the if you just analyze the the packet header of MQTT protocol, right? So there something called telemetry header. So telemetry headers is, I think, around 4-bit length. Okay, so that 4-bit length is basically used to identify each packet in with its own identity, right? So have you worked on that level?
No, sir.
Yeah, so basically there is a 4-bit header which we can use it for transferring data with a secured way. So every time you receive, you can change with 16 different combinations. Since it is a local data, I think 16 different combinations and different data elements. So we can certainly achieve security with MQTT protocol as well. So there are certain other advanced protocol also, but it depends on really do we need to, because once you increase the number of keys or the length or number of bits in the header length, so it is going to certainly create delay in the network, and
Yes,
therefore
sir. Right, sir.
it will delay the whole transmission, right?
Mm-hmm.
So therefore, it is essentially important how critical information you're transferring. Like for transferring simple data, which is being just like vibration sensor data, I cannot use 16-bit security code, right? So it will take a lot of time. For even for processing, we need high processing capabilities, and then for bandwidth is high, requirement of bandwidth is high. Therefore, depending on the criticality of application, we can use different security protocols.
Okay.
Yeah.
Any other questions? Okay, Vidya sir, so from the organizing team, I extend our heartfelt thanks for sparing time for this wonderful session and giving us insights about the industry that you work on and the kind of technology that you're using. Hope the participants would have been benefited, definitely.
Thank you so much for patiently listening to me. And
it was our pleasure, sir.
Thank you so much.
It is a token of gratitude from our side, so kindly accept it. We can do it virtually only.
Sure. Thanks a lot.
And at the same time, we'll present a certificate as well.
Sure. Thank you so much. All right. So if in case you have any queries, you can reach me out. I think I'll drop my email ID and contact details with the organizers. Right.
Sure.
It was wonderful being with you this evening, and thank you so much for having me here.
Same here.
Thank you, Vidya sir.
Thank you.
Thank you, sir.
Thank you, ma'am. Thank you. Bye.
Okay, sir. Thank you.
Thank you very much, sir.
Thank you, sir.
Okay, CD ma'am.
ठीक है, wind up.
Okay.
Thank you all. Good night.
I request the organizing team to share the contact detail of Dr. Bala.
Sure, sir. We will do.
Sir, coming week we will provide all the speakers and expert
Yes.
details.
Yes.
Thank you.
Okay. Thank you.
Good night.